The student conducts an experiment and records the following data for two variables, x and y here. Okay, and it says then that x and y can be modelled by this equation here, this exponential equation here. All right, that's the relationship that exists between them. Okay, so we know there's an exponential sort of growth here, and if you notice here, you can think of x, maybe this is like the time, isn't it? You know, so after 1 hour, there's 14 maybe bacteria or something. After 2 hours, there's 45 bacteria, and so on. And you can see that it grows really rapidly, so exponentially. After 6 hours, there's 3,400 bacteria. So what we're asked to do then, right, is to work out, first of all, in this table, what log of y is of these y values. Okay, so all you've got to do is in your calculator, okay, the log button to the base 10, instead of using that there and put in the base 10, you can press shift and minus, yeah? Shift and minus there, and it comes up with the logarithm to the base 10, okay? And if we put in 14 to start with, okay, we get then 1.146, okay? And all you've got to do is go back and type in the others. So 45 is 1.653. Now, I did all the others earlier on, so I'll just fill these in here, okay? And then the point is, we're then asked, essentially in a minute, we're going to be asked to plot these points on here, okay, as it says there. And what you should get is a linear relationship, okay? It should be straight line, okay? If it's not a straight line, okay, if the points are all over the place, then this won't hold, okay? But we're told that this relationship exists, that it grows exponentially. So if it grows like this, then we are going to have a straight line here. So if we plot the points, okay, so essentially when x is 1, log y will be 1.146. So across to 1, and then we go up to 1.1. Okay, 1.1 is as accurate as I can get it to be. There's 1.1 there. When x is 2, 1.65, yeah? So 1.65 will be about there. When x is 3, 2.1. Okay, so up to 2.1, which is about here. X is 4, 3.0. Okay, which is there. X is 5, 3.11. So what have we got there? 3.11, so it's about there. X is 6, then 3.5, so it goes here. It says then in part B, in the question, state with a reason which value of y is likely to have been recorded incorrectly. So when they mean recorded incorrectly, obviously there's a mistake here, okay, with one of these. They've made a mistake here. The reason why we'd expect it to be a mistake is because we're expecting a line here, aren't we? Okay, now when you look at this here, there is sort of a line forming, but that one kind of sort of goes against that relationship, doesn't it? So it's that value of y there, okay? So we can simply say, okay, in part B here, we can put our answer, when x equals 4 and y equals 1100, okay, that's the value that is recorded incorrectly. Okay, and the reason is because it fails to obey the sort of linear relationship, okay, or the linear pattern that exists, that clearly exists there. Okay, so that one there is, on my graph, is clearly wrong, yeah, that one is out of place there, okay, compared to the other points. So in part C, it says, by drawing an appropriate line, find the values of k and b. So let's draw a line. Essentially, when I draw that line, it's going to go through these points, or near enough, right? Okay, so you could see there, okay, more or less there, got that, with all the points going through that line, yeah? Apart from that one, of course, which we know is recorded incorrectly. So then it says, find the values of k and b. Now, to do that, first of all, we need to look at the relationship that exists here, this exponential sort of equation here. Okay, so we've got that. Now what I want you to do is to take logs of both sides, okay? And it will be log to the base 10, because that's what we've got values here, log to the base 10. Okay, but I'm just going to write log, of course, don't need to write the base. So log of that side then, like that. What you do then is split up this logarithm here. And because it's k times bx, I can say log k plus log b to the power x. And then, of course, what I can do is bring that power down. Okay, because it's log b to the power x, bring it down. So I got that there. Okay. The other thing I'm going to do then is, right, I'm going to write this at the start. And in fact, I'm going to write log b in a bracket, x plus then log k. So you'll see why I've done that now in a minute. Okay, it might make sense to you. But write that at the start. Okay, swap them around and put the log b at the front there. Now, what I want you to appreciate then is, okay, is what's going on here, because log y is simply your y-axis, isn't it? Okay, it's your y-axis there. So I can call that big Y, if we think of that as my y-axis there, capital Y there, right, equals 2. So the log b of x then, okay, plus then the log k. Okay, now I want you to appreciate then what we've got here. This is looking similar to, of course, y equals mx plus c, yeah? Okay, y equals mx plus c. That's why we've got a straight line. We've got a straight line existing because the values obey this exponential here. And when you take logs and so on, it ends up coming to look like this, which will be straight line format, where essentially, okay, y then, of course, is your log y values, but more importantly then, you can work out what your m is and what your c is. So your m is equal to log b, in other words, the gradient, and your c, which is log k, and remember the c is the y-intercept.